Let's start with the very important topic, rate of reaction. Rate of reaction. What is the meaning of rate of reaction? What is the meaning of rate of reaction? Rate of reaction, it is as we measure the speed. It is as we measure the speed. Speed means whenever we travel anywhere, from our school to our home, we measure the speed, means how much time we will take to reach from home to school. See, the rate of reaction tell us about the speed of reaction, means how much time it take to complete. The rate of reaction means the speed of reaction, we can say the speed of reaction. The next question arises, how we can calculate speed. How we can calculate the speed of reaction? Means to calculate the speed, we having two parameters, one is distance and second is time. So how can we calculate the speed of reaction? To calculate speed of reaction, we have two parameters. First is concentration of, that can be of reactant or that can be of products. Second thing, the time. Second thing is time. By these we can calculate the speed of reaction. The next question arises, can we calculate the speed of every reaction? Can we calculate the speed of every reaction? We having three type of reaction. First type of reaction on the basis of speed, or we can say on the basis of rate. The type of reaction we having on the basis of rate. First is the fast reaction. Fast means the reaction which occur in microseconds. The ionic reactions are generally consider in fast reaction. For example, BaCl2 aqueous, when react with sodium sulfate aqueous, then the formation of BaSO4 in terms of solid, we can say precipitate plus 2 mole of NaCl, means the reaction which occur very fast, the reactions which occurs in microseconds, you can say microseconds, these are considered as the fast reaction. So is it possible to calculate the rate of reaction of these reactions? No, we cannot calculate the rate of fast reaction. We cannot calculate the rate of fast reaction. The second type is slow reaction. The reactions which occurs in the long time period. For example, rusting of iron. We have study about two type of reaction. First is fast reaction, second is slow reaction. Fast reaction which occur in microseconds. Whenever the reactant are mixed, the reaction is sudden complete. Second is the slow reaction which occur in long time period. For example, whenever the rusting occur on the iron, that is known as slow reaction. So, Slow reaction, the rate of slow reaction cannot be calculated because it is too long to calculate. So, we cannot calculate rate of reaction of these reaction. The third one is the moderate reaction. Moderate reaction means which are not so fast, which are not so slow. The next type of reaction is third type, that is known as moderate reactions. Moderate reaction, the reactions which are not so slow and not so fast. We can calculate the rate of these reactions. For example, the decomposition of H2O2, formation of H2O plus O2. The decomposition of this reaction can be calculated. So, this is considered as moderate reaction. We studied about three types of reaction. First is known as fast reaction. Fast reaction are those which occur in microseconds. Second is slow reaction, the reaction which take long time to complete. And the third one is moderate reaction. Moderate reaction lie between the fast and slow reaction. Moderate reaction, the reaction which are not so slow, not so fast. For example, decomposition of hydrogen peroxide. We can say this is the decomposition of hydrogen peroxide. One another example is PCl5 gas. Whenever it changes into PCl3 gas plus Cl2 gas. This is also an example of moderate reaction. These reactions are those by which we can calculate the rate of reaction. Our next thing is how we can calculate the rate of reaction. Rate of reaction means speed of reaction. To calculate the rate of reaction, please first note down each and everything. Okay, next we started with the rate of reaction. The rate of reaction. Rate of reaction. The rate of reaction. The rate of reaction can be calculated in terms of reactant as well as in terms of products. In terms of product. For example, R, let us consider this R is a reactant. Let us consider this R is reactant and that is converting into the product P. That is converting into the product P. Then how can we write the rate of reaction? How can we write the rate of reaction? We can write the rate of reaction. Rate of reaction is change in concentration with respect to time. Change in concentration with the rate of reaction is change in concentration with respect to time. The concentration of reactant as well as of products. Means rate of reaction is change in concentration. Means let us consider we started a reaction. Having reactant R. Its concentration at initial time, initial time is 5 mole per liter. At initial time means when the reaction just started, then the concentration of product is 0. जब आपकी reaction start होती है, that time the concentration of product is always 0, but the concentration of reactant is always something. After time t, concentration of reactant becomes 2.5 mole per liter. So after time t can be 5 minutes, 6 minutes, 7 minutes or seconds also. The concentration of reactant remains 2.5 mole per liter, then the concentration of product is 2.5 mole per liter. Then how can we calculate the rate of reaction? Rate of reaction in terms of reactant, that is negative change in concentration of reactant, divided by change in time. We also can write this minus change in concentration of reactant with respect to time. Change in concentration with respect to time. This minus delta R, represent the change in concentration of reactant, and delta T represent change in time. How can we calculate the change? Delta R is equal to R1, R initial minus R at time t. This is the initial concentration, and this is the final concentration. To calculate the change, we can minus RT minus R naught. RT is the final concentration at any time. R naught is initial concentration at time of starting reaction. मतलब whenever we calculate the change, whenever we have to calculate the change, that time we minus the initial concentration from the final concentration, और the final point में से हम अपने initial point को क्या करते हैं, minus. So delta R is equal to RT. RT is known as final concentration at any time t. R naught is the initial concentration of the reactant. Here I put negative sign. This negative sign only represent the decrease in concentration of reactant. It only represents the decrease in the concentration of reactant. Is it clear? Next, this is the rate of reaction in terms of reactant. Again we start. Rate of reaction. What is the rate of reaction? Rate of reaction can be calculated in terms of reactant as well as in terms of products. For example, let us consider we having a reactant R that is changes into product P. Is it clear? There is a reactant R that converted into the product P. Let's consider the initial time, means we can say T is equal to 0 as the reaction started. As the reaction started, the concentration of reactant initially is 5 mole per liter. Okay, the concentration of product is 0. After certain time period, means when the reaction proceed, that time the concentration of reactant is 2.5 mole per liter. The concentration of product is 2.5 mole per liter. Is it clear? Okay. We calculate the rate of reaction. Rate of reaction can be calculated in terms of product as well as in reactant. So, the definition of rate of reaction is the rate of reaction is defined as the change in concentration of reactants or change in concentration of product with respect to time taken. Means the rate of reaction is defined as the change in concentration, means how much change in concentration of reactant or change in concentration of product with respect to time taken. Let us consider a reaction R. Let us consider a reaction in which the reactant R changes into product. This is the reaction. The R represent the reactants, and P represent the product. Rate is equal to rate of reaction is equal to negative change in concentration of reactant divided by the change in time taken. Also this can be written as change in concentration of product divided by the change in time taken. Means the rate of reaction can be calculated in terms of change in concentration of reactant, change in time taken, or we can say change in concentration of product with respect to the change in time taken. We can write down this rate of reaction is equal to negative change can be represented in terms of delta. I am again writing that change can be represented in terms of delta, change in concentration of R with respect to time. Again, change in concentration of product with respect to time. Okay. This delta represent change. And this square bracket tell us about the molar concentration. Of reactant, or you can say products. This delta represent the change. Change means what is the change occur from initial condition to the final condition, and this square bracket represent the molar concentration of reactant. Okay, how can we write down the delta R? Delta R is equal to R2 minus R1, and delta T can be represented as T2 minus T1. Delta P can be written as P2 minus P1. Okay. Can you get the point why I write negative here? Whenever I am writing the rate of reaction is the negative change in concentration of reactant, change in time taken, or change in concentration of product with respect to the time taken. Here I put a negative sign. This negative sign is very important. Why I put this? This negative sign indicate the decrease in concentration of reactant. This negative sign tell us about the change, the decrease in concentration. Again I am writing here the negative sign before change in concentration of reactant indicate us that the concentration of reactant always decrease as reaction proceed. This is the very important thing, कि why we put the negative sign in front of whenever we are writing change in concentration of reactant. This negative sign tell us about the change in concentration, indicates that the concentration of reactant always decrease as the reaction proceed. Clear? Okay, again I am concluding this. The rate of reaction is defined as the change in concentration of reactant or change in concentration of product with respect to time. Okay, I am taking a reactant R, that is changes into the product P. So the rate of reaction for this reaction is change in concentration of reactant, change in time taken. That is also equal to the change in concentration of product, change in time taken. We can write down mathematically the rate of reaction is equal to negative change in concentration of reactant with respect to time. Again that is equal to the change in concentration of product with respect to time taken. This delta represent the change, this square bracket represent the molar concentration of reactant, or you can say product. How we calculate the delta R? Delta R can be calculated R2 minus R1. This R2 is final concentration of a reactant. This R1 is initial concentration. So again the T2 becomes the final time taken, T1 is the initial. Delta P is equal to P2 minus P1. P2 is the final concentration of product and P1 is initial concentration of product. Again I am writing the negative sign which I put here and also put here. This represent that the concentration of reactant always decreases as the reaction proceed, means as the reactant gives the product. In mathematical expression we write down the rate of reaction is equal to negative change in concentration of reactant with respect to time, that is also is equal to change in concentration of product with respect to time. We understand this thing, means whenever rate of reaction is calculated, that is always is equal to in terms of reactant is same to in terms of product. Let us consider again the same reaction R changes into product P. When time is 0, time 0 means just the reaction started. Time 0, it means the reaction just started. The reaction is just started. As the reaction started, there is no product. So the concentration of reactant is 5 mole per liter. The concentration of reactant is 5 mole per liter. Then the concentration of product is 0. At time T, this is the initial time, this is the final time T. We can say after 5 seconds. After 5 seconds, the concentration of reactant remains 2.5 mole per liter. 2.5 mole per liter. The concentration of product becomes 2.5 mole per liter. Is it clear? I am taking that at the initial time when the just reaction started, the concentration of reactant is 5 mole per liter. The concentration of product is 0. At the time T2, means as the reaction proceeds, the concentration of reactant becomes 2.5 mole per liter. The same the concentration of product becomes 2.5 mole per liter. हमारे पास जितना reactant था that converted into the product. So now we calculate the rate of reaction. Rate of reaction is equal to negative change in concentration of reactant with respect to time. Is it clear? Okay. That is equal to R2 minus R1 upon T2 minus T1 and the negative sign. Is it clear? Okay. The R1 is initial concentration is equal to 5 mole per liter from the above data, and T1 is, that is 0 second. Okay. R2 is 2.5 mole per liter, then T2 is equal to, that is 5 second. Putting these data, okay, rate of reaction is equal to negative R2 is 2.5 minus R2 is 2.5 minus R1 is 5 divided by T2 is 5, T1 is 0, that is equal to minus 2.5 minus 2.5 and 5, that is is equal to minus minus plus 2.5 upon 5, that becomes is equal to 0.05 mole per second. Okay, how I calculate this? This 5, if I am remove this point, then that is divided by 10, 5, and this can be write as 0.5 mole per liter. This can be write as 0.5 mole per liter. Means the rate of reaction in terms of reactant is change in concentration of reactant. Change in concentration of reactant can be written as R2 minus R1 divided by T2 minus T1. The R1 is 5 mole per liter. R1 means as the reaction started. R1 means as the reaction started. R2 is after some time T2, that is 2.5. R1 is 5 mole per liter. T1 is 0 second. R2 is 2.5 mole per liter and T2 is 5 second. Putting these data in this formula, the rate of reaction is equal to negative R2 2.5 minus 5. 5 is the initial. This can be written as that having the unit mole per liter. T2 is 5, T1 is 0, this having unit second. Okay, we can write down this is mole per liter per second. This becomes mole per liter per second. This also becomes mole per liter per second. Okay. 2.5 minus 5, that gives you the minus 2.5, minus minus becomes plus divided by the 5, it is become 0.5 mole per liter per second. How this calculation occur? Dekho, 25, if I remove this digit point, it becomes divided by 10, 5 divided by 25, that becomes 5, and this unit is mole per liter. Is it clear? Now we calculate rate of reaction in terms of product. Delta P upon delta T is equal to P2 minus P1 upon T2 minus T1. P2 is equal to, from the given data, P2 is 2.5, that is 2.5 mole per liter. So P1 is 0 mole per liter and T2 is T2 is 5 second and T1 is 0. Putting these data in this, that becomes is equal to 2.5 minus 0 divided by 5. This is mole per liter, this is second. This again becomes 2.5 upon 5 mole per liter per second and it becomes 0.5 mole liter per second. It means this is as it is as of in terms of a reactant. This shows whenever we calculate rate of reaction in terms of product or in terms of reactant, that always remains same, because the disappearance of reactant always is equal to the appearance of a product. I think this is clear. I am again telling you this in terms of formula. Rate of reaction, that is equal to change in concentration of reactant with respect to time, that is also is equal to change in concentration of product with respect to time. We calculate the rate with the help of some datas. Let us consider the reactant, the concentration of reactant is 5 mole per liter at the time initial. So, the concentration of product is always 0. After time t, let us consider that time is 5 seconds. The concentration of reactant becomes 2.5 mole per liter. So, the concentration of product again becomes 2.5 mole per liter. Rate of reaction, change in concentration of reactant. Putting all these datas, we calculate the rate of reaction in terms of reactant is 0.5 mole liter per second. Rate of reaction in terms of product is equal to the same 0.5 mole per liter. Means whenever we calculate rate of reactions in terms of reactant or in terms of product, that always remains equal. Let me write down some more rate of reaction in specific reactions. Okay, if I am having, okay, try to write down, I am having a reaction PCl5 changes into PCl3 plus Cl2. Try to write down the rate of this reaction. How will you write down the rate of this reaction? The rate of reaction for this reaction is equal to, what is this? Negative change in concentration of PCl5 divided by the change in time taken. Because whenever we writing the rate of reaction, that can be written in terms of reactant as well as in product. In terms of reactant, what is the rate of reaction? Rate of reaction is change in concentration of reactant with respect to time containing the negative sign. That is equal to change in concentration of PCl3 divided by time taken. Again equal to the change in concentration of Cl2 with respect to time taken. Okay, we start writing the rate of reaction in terms of some specific reactions. I am taking an example of PCl5, that is changes into PCl3 plus Cl2. To write down the rate of reaction for this reaction, rate of reaction is equal to negative sign, change in concentration of reactant with respect to time, change in concentration of product with respect to time, and change in concentration of product with respect to time. I can say that rate of reaction of which decomposition of PCl5 is equal to change in concentration of PCl5 with respect to time, that is again equal to the change in concentration of product is PCl3 with respect to time equal to the change in concentration of chlorine with respect to time. I am writing one more reaction, Ag plus Cl2 changes into AgCl2. Try to write down the rate of this reaction. I think the rate of reaction is equal to change in concentration of Hg with respect to time. Okay, that is equal to change in concentration of chlorine with respect to time, and this is equal to the change in concentration of HgCl2 with respect to time. Okay, we are always take the concentration of solid 1, हम इसको बाद में डिस्कस करेंगे. So we can write down the rate of reaction of any reaction in terms of reactant or in terms of product. Is it clear? How we can calculate the rate of reaction if we having some specific reactions? Okay, in these reaction, the stoichiometric coefficient means the balancing coefficient. In first reaction, PCl5 changes into PCl3 plus Cl2. The stoichiometric coefficient is 1, 1, 1. Same in second equation, the stoichiometric coefficient of mercury is 1, chlorine is 1, AgCl2 is 1. There is no any problem to writing the rate of reaction. If we have some reaction in which the stoichiometric coefficient is not 1, for example, N2 plus H2 changes into ammonia. If I am balance this reaction, so then time, this is the balancing reaction. How can we write down the rate of reaction? Okay, I am repeating the whole thing. PCl5 whenever decomposed, that converted into PCl3 plus Cl2. I can say that 1 mole of PCl5 converted into PCl3 and chlorine. 1 mole converted into 1 mole and 1 mole of Cl2. Means I can say the rate of decomposition of PCl5 is equal to the rate of formation of PCl3 and chlorine. Please listen it carefully. Whenever the rate of decomposition of PCl5 is equal to the rate of formation of PCl3 and Cl2, whenever the stoichiometric coefficient is 1, 1 and 1. Same happen with this reaction. When 1 mole of Ag react with 1 mole of chlorine, then formation of 1 mole of AgCl2. It means the rate of disappearance, the meaning of disappearance means the Hg is converted into the product. The rate of disappearance, I am writing here the rate of disappearance. Disappearance means change into product. Is equal to rate of disappearance of chlorine, rate of disappearance of chlorine equal to formation, rate of formation of HgCl2 of HgCl2. Are you getting this? Means whenever we having 1, 1, 1 stoichiometric coefficient of reactant and product, that time the rate of disappearance or rate of appearance, rate of formation, or you can say rate of appearance are same. Means the amount of reactant disappear is equal to the amount of product form in case when the stoichiometric coefficient is 1. But what happen when the stoichiometric coefficient is not equal to 1? What this reaction describe? This describing that 1 mole of nitrogen react with 3 mole of hydrogen, then the formation of 2 mole of ammonia. It means what the reaction is saying in terms of rate of reaction. The rate of disappearance of, I am writing rate of disappearance of nitrogen equal to 3 times rate of disappearance of, the rate of disappearance of nitrogen is equal to the rate of disappearance of hydrogen, but this is not correct because there are 3 moles are using, yani ki it means 3 times the rate of disappearance of nitrogen is equal to the rate of disappearance of hydrogen, means 1 mole of nitrogen reacting with 3 mole of hydrogen, it means the speed of nitrogen is more as comparison to hydrogen. The speed of nitrogen is more as comparison to hydrogen, and that is equal to rate of appearance of ammonia. Again, the ammonia having 2 coefficient. So, in the cases when we don't have the 1 stoichiometric coefficient, that time it is not easy to write down the rate of reaction in simple way. So, to write the rate of reaction, we write down that is negative change in concentration of nitrogen with respect to time, that is equal to minus 1 by 3. You are thinking that why I am putting minus 1 by 3. Minus 1 by 3 means the rate of disappearance becomes equal to the rate of disappearance of hydrogen, because the rate of disappearance of nitrogen is 3 times than the disappearance of hydrogen. Again I am telling you, here the reaction nitrogen react with 3 mole of hydrogen, then changes into 2 mole of ammonia. In this reaction, the rate of disappearance of nitrogen is 3 times of rate of disappearance of hydrogen, because in this reaction 3 mole of hydrogen reacting with nitrogen. और अभी हमने थोड़ी देर पहले पढ़ा था कि rate of reaction in terms of every reactant or in terms of every product always remains same. To make the rate of reaction same, the rate of reaction is equal to negative change in concentration of N2 with respect to time minus 1 by 3. Minus 1 by 3 I am putting to make the rate of disappearance of nitrogen and the rate of disappearance of hydrogen equal. I think you get the point. That is equal to 1 by 2 change in concentration of ammonia with respect to time. I am dividing by the stoichiometric coefficient to these rate to equal the rate of reaction in terms of reactant as well as in product. I think you get the point. Okay, write down the one more reaction. Write down the rate of reaction for this reaction. I think you clear this. Write down the rate for this reaction. The decomposition of peroxide, 2 mole of hydrogen peroxide changes into H2O plus O2. Write down the rate. What is the rate? How can you calculate the rate of reaction? As per my concern, you are writing that rate of reaction is equal to, very good, minus 1 by 2 change in concentration of H2O2 with respect to time, very good. That is equal to change in concentration of water with respect to time, that is equal to change in concentration of oxygen with respect to time. I think you get the point why I divide the stoichiometric coefficient, because to finding the rate of reaction in terms of product or in terms of reactant, I am just using to divide this stoichiometric coefficient, because the rate of reaction whenever we are measuring in terms of reactant or in terms of product, that always remains constant. Is it clear? I think it is clear. This is the mathematical expression for all the reaction having, we have to calculate the rate. So, okay, we solve a numerical. In this numerical, we have a statement for a reaction. Reactant changes into product. The concentration of reactant changes from 0.03 mole to 0.02 mole in 25 minutes. Calculate the rate of reaction. We have to calculate the rate of reaction. The reactant R changes into product P. The numerical is saying that initial concentration is 0.03 molar when time is 0. After time, that time is 25 minutes. The time is 25 minutes. The concentration of reactant becomes is equal to 0.025 molar. So we have to calculate the rate of reaction. The rate of reaction is equal to change in concentration of reactant with respect to time. That change can be represented as R2 minus R1 divided by T2 minus T1. We having T1 is 0, T2 is 25 minutes, and this is our initial concentration and this is our final concentration. Putting all these data into the formula, R2 is minus 0.02 molar minus 0.03 molar divided by, the time is 25 minutes minus 0. The unit of concentration is capital M. Capital M means mole per liter, and the unit of time is minutes. The unit of time is minutes. This can be written as minus, this becomes minus 0.01 divided by 25. This is multiplied by 60 because we are converting the minute into the second. So the unit becomes mole per liter per second. So it becomes is equal to minus plus 0.01 divided by 25 multiplied by 60. Can you calculate this? Try to calculate. If you calculate, you give the answer and the unit is mole per liter per second. I think you can calculate the numerical easily. Next thing is how we can calculate rate of reaction in different manner, different way. First is we can calculate the rate of reaction in average. First is average rate of reaction, and second way is instantaneous rate of reaction. We are having two ways to calculate the rate of reaction. First is average rate of reaction and second is instantaneous. Average means we took total concentration divided by the total time taken, and instantaneous rate of reaction is to calculate rate of reaction for the small interval. Means first the average, I am writing this here, average rate of a reaction. The average rate of reaction